Get this show on the road. Welcome back to the, is it spring semester 2009 already? Version of the W.S. Carlson International Polar Year events. First one of this semester. And I guess I can say good afternoon because the days are getting long enough so that that phrase no longer has any ambiguity. I'm Fritz Nelson from the UD Department of Geography. And with Lisa Griffiths of the Center for International Studies, I co-chair the Carlson IPY events, of which today's talk obviously is one. And before turning the lectern over to Tom Geiser, who will introduce today's speaker, I'd like to say a few words about a scientist who worked at this university for many, many years. Tom is the Martin A. Pomerantz Professor of Physics and Astronomy at the University of Delaware. Many of you will certainly already be aware of the significance of that title in our university, but I think it's appropriate to say a few words about that before we proceed further. Martin Pomerantz headed UD's Bartol Research Institute from 1959 until 1986, quite a stretch. He was one of the first scientists to use Antarctica for astronomical and astrophysical observations. He carried the National Geographic Society's flag to the South Pole in the late 1950s. The Pomerantz Observatory at the South Pole, which is shown on the right side of the screen here, is named for him. His research in Antarctica continues through UD's Department of Physics and Astronomy, and the Pomerantz Chair of Physics and Astronomy was established through a very generous gift by Martin Pomerantz and his wife in 1999. Martin Pomerantz passed away in October 2008 at the age of 91. Just change the slide here. Pomerantz was an extraordinary, absolutely extraordinarily important figure in polar science. The special announcement of his passing, which is shown on the screen here, was issued by Carl Erb, the director of NSF's Office of Polar Programs. The announcement read, in part, Dr. Pomerantz was literally a legend in Antarctic science for his vision and dedication to the field of astronomy. Those who knew Martin described him as an extraordinarily gifted scientist with an incredible breadth of talents. Almost single-handedly, he recognized the value of one of the world's most remote and inhospitable places as an ideal place to study the physical origin of the universe and other complex astrophysical phenomena. He led quite a life, and he leaves quite a scientific legacy. So from this, you can see exactly how appropriate it is to have Jerry Marty from the National Science Foundation's Office of Polar Programs here today to tell us about the construction of the South Pole Station. But before I turn the lectern over to Tom, I would like to invite Ian Jansen, who is the director of the University Archives and Records Management Office, to make a brief announcement that I think is very germane to the discussion here today. Thanks very much. Oh, don't forget, there's also a reception following the talk upstairs under the dome in Memorial Hall, a little after 6 o'clock. Ian.
Thanks. Can everybody hear me? It's for the web, so but bear with me. I'm an archivist first and a public speaker second. All right. What I'd like to speak with you today is to inform you about an exciting acquisition by the university of a large collection of papers and records belonging to Dr. Pomerantz. In late 2007, a representative from the American Heritage Center at the University of Wyoming contacted me. That institution was deaccessioning several large collections that it possessed for many years, but was unable to process or provide access to researchers for. Included among these collections was a large lot of papers produced by or related to Dr. Pomerantz, his polar research, and his work within the Bartol Research Institute. While the history of these materials is somewhat unclear, what is clear was the importance of these records to understanding the historical development of that research institute and of his work. The offer was accepted, and in February of 2008, 2 shipping pallets containing 65 cubic feet of records, which is about 55 boxes of records, were delivered to the university. In December of 2008, an initial processing survey of this material began, which is continuing at present. It will probably be done next month. It is anticipated that final processing will commence during the latter half of this year, after which time the collection will be made available to the public. Contained within the Pomerantz collection are many different types of documentation and records, including correspondence with polar stations, site reports from polar stations, administrative files from the Franklin Institute and the Bartol Research Institute, photographs, manuscript drafts, and lecture notes. This material ranges in date primarily from the 1950s to the 1970s, although some of it is as early as the 1930s. University Archives and Records Management is the primary repository for historical records related to the history of the University of Delaware. The Pomerantz collection greatly enhances its existing collections, which the university community is encouraged to use. This unit always is interested in acquiring records, images, objects, or information related to the university, its history, and specifically to this collection. So if anybody has any wisdom to share on Dr. Pomerantz and his work, we're definitely willing to hear what you have to say. Thank you.
Thanks very much, Ian. Tom?
Well, I want to thank Fritz very much for introducing the role that Martin Pomerantz has played. And before I introduce Jerry Marty, our speaker tonight, I wanted to say a little bit from my perspective about about how the work in Antarctica and in polar regions in general got connected with the University of Delaware and with the Department of Physics and Astronomy. And the answer, of course, is through Martin Pomerantz. He started working at Bartol Research Institute in 1938 when he was a graduate student at the University of Pennsylvania. And this is just a list of some of the projects that he's been involved in. There are a couple more slides that continue this list in Antarctica and in Greenland. The neutron monitor in Thule, Greenland, as far as I know, is still running now. Maybe it's not the same one, but it's part of the Bartol network of neutron monitors. Then in 1960, he's built a neutron monitor at the South Pole, and in at McMurdo on the coast, and in 1963 at the South Pole. This is a picture I took out the window from my room at about a couple of years ago, and some of my colleagues here will recognize it. This is the neutron monitor, and the building here is called Skylab, which is where the thing was run from. And here's this picture on the top here is a picture of me in 1995, which was the first time I visited the Cosray, it's called Cosray station in McMurdo, and it has this nice Travelodge sign on it. The connection to what we're doing now comes through this picture here, which is a picture of the second version of the South Pole air shower experiment, which we built in 1994-95, and that was after Martin Pomerantz had retired. He, working with the University of Leeds, had built a predecessor experiment on the other side of near the South Pole station, and we, Paul Evenson and I and others, working with Alan Watson at Leeds, built the second version to work with an experiment that was being built under the ice called Amanda. Now, coming back to Martin, this is what Carl Erb was referring to in his statement that he made commemorating Martin Pomerantz. He was also interested in using the South Pole for astronomy, and this is the first cosmology observation from the South Pole, and the people, Martin Pomerantz is in the middle, and it was a Bell collaboration between Pomerantz at Bartol and AT&T, whose flag is flying over the experiment there. And so the heritage is shown by is indicated by this picture here. this is what we're doing now. We're building a deep detector called IceCube with that goes down 2.5 kilometers in the ice. And the drill with hot water here makes the holes, and the optical modules go into these holes. And you see the heritage lined up here. On the left, the building on the horizon on the left is the South Pole Telescope, which is a descendant of that earlier version of the cosmology experiment. This is a cosmology telescope making use of the high altitude and the very dry air. It's the principal investigator is John Carlson at the University of Chicago. And on the right, on the horizon, you see the Martin A. Pomerantz building, which has been used for a variety of astrophysical and astronomical experiments, but it's also the nerve center for the Amanda experiment, which was the predecessor of IceCube. So this picture, and in fact, I took this picture. You see the shadow of on the lower left-hand corner, the shadow of the South Pole Air Shower building, which is now used by surveyors. And I had an opportunity to take a picture of the drill towers and of one of our ice top tanks you see there just above the red building. So this is, in a brief way, the connection of the past and Martin Pomerantz that you heard about from Fritz with what we're doing now. Now, I'm very pleased that several of the people working in our group at South Pole are here in the audience, and especially Paul Evenson, who got in at 2 o'clock this morning, I think. And I want to give a special welcome to Len Schulman, who had a long trip back. And now let me introduce Jerry. Jerry is the facilities construction manager for Antarctica in the Office of Polar Programs of the National Science Foundation. I first met Jerry in 1995 when we were building the space experiment that's shown in the shadow there. Jerry received his construction engineering degree from the University of Wisconsin in Platteville in 1969, and which is an interesting thing because five of the people working on IceCube, this experiment here, also are engineers from the same University of Wisconsin branch in Wisconsin. He first went to Antarctica in 1969 as a GA, which means general assistant, general dog's body, working on whatever needed to be done at the Bird Station. And after serving a tour in Korea guarding the DMZ, he returned and started working at the South Pole. And he's spent a total of 4.5 years of live time, of elapsed time, living at the South Pole over the years. And he's been the South Pole construction manager from 1994 to 2009. Now I want to show you just one more picture. This is so when Jerry first went to the South Pole, his job was to manage the occupancy or moving into the dome, which is the second South Pole station. And then since the mid-90s, his job was to manage the construction of the new station, which is shown in the foreground here. And he claims that he's going to retire this summer. And so when he left the pole this year in December, there was a ceremonial departure, and I had to ask somebody to explain to me what makes the arcade of swords. Those are carpenter's rules. And so people were seeing him off on his departure from the South Pole. So it's a great pleasure, and I hope you'll join me in welcoming Jerry Marty to tell us about building for science at the South Pole.
Just click this. Thank you, Dr. Geiser. It's a real treat and honor to be here this evening. And Tom has given me an itinerary to discuss, and as soon as we bring up the presentation, he also indicated that we have 45 minutes. I have 45 minutes to go through this, and he indicates he has a hook that'll pull me off the stage if I run a little bit long. But so bear with us as we bring up the presentation. It's hard to believe, Tom, that it has been that long ago that we started in '94 with that particular project, Phase 2. If I stand here with the mouse, is that going to work for everyone? Okay, without pulling the laptop off the table? Okay, sorry. Is it the left or the right that advances? Okay. Okay. The title, as Tom had selected, will be a presentation regarding the building of science, or the new South Pole Station, along with the chronology of exploration. So I thought I'd break it down into the following components. Antarctica, a continent is born, early exploration and research stations, and then the International Polar Year and what that really means. And who is the National Science Foundation, and how are they organized, and how are they funded? The Jerry Marty role that Tom alluded to actually spans almost 40 years. And then the South Pole Science, 1956, which is the first scientific research station built at 90 degrees south through the present. And then the new South Pole Station, which is a platform for 21st century science that we've just completed, which supports two major projects, one of which is the Ice Cube project and Ice Top. And then the future. South Pole is changing, so the science and the platform for science is changing as we move into the middle of this decade. And then questions. Okay, where is Antarctica? Antarctica is at the bottom of the planet Earth. And in total, it represents a west side and an east side, and it has 3 U.S. stations that are year-round occupied stations. And the difference between the North Pole and the South Pole is the South Pole is a continent surrounded by oceans and or water, and the North Pole is basically floating ice mass or water surrounded by continents. Go back. Okay. Okay, bear with me. Yeah, if I could, please. Okay, I could do that. Okay, let's go back one more. The continent of Antarctica, when we talk about scientific research and the interest in the continent, is really twofold. Number one is it's not a small landmass. It is one of the 7 continents. And when you look at it with the United States superimposed over it, it's basically larger or as large as the United States and Mexico combined. And from a scientific standpoint and interest, one needs to think of that amount of land mass that is 90% covered in ice, and in some cases the ice, it's 90% covered in ice. In some cases the ice is over 2 miles thick. That represents 5 million square miles of ice, and 70% of our planet's fresh water is in that large ice cube. So in terms of what's happening on our planet Earth today, what's happening tomorrow and the future for our children and the planet, this is certainly a location for scientific research. The continent didn't just find itself there a few years ago. Bear with me, I'll have this mastered yet. 200 million years ago, as the landforms. Is there a time on it? So I have to speak faster? Is there a time? Is that it found its way? It's 200 million years ago. It was 65 degrees south latitude, just coming into the Antarctic Circle. You can see South America here. 80 million years ago, it was starting to approach what is known now as 90 degrees south latitude, the geographic bottom of the planet Earth. What's interesting is dinosaur remains, fossils, that have been found on the continent today relate to when the continent was 65 degrees south latitude, or 190 million years ago. So this block of ice, this continent, as large as the United States and Mexico, was one large Jurassic Park. So the secrets of the evolution of the planet Earth in the future lie buried beneath all of that ice. The first explorers actually started with James Cook, Captain Cook, and in his 3 voyages circumnavigating the planet Earth, he basically got south of 60 degrees, and then unfortunately the mishap in Hawaii. In 1939, 1940, it was Ross. And this sequence of slides will show you that as the years move forward, the sealers, the whalers, and the explorers and technology started to move people closer and closer to this unknown continent, Gondwana land, the driftless continent, and we were starting to understand it, most importantly from not only a research or a exploration standpoint, but from a source of revenue, the sealers and whalers. And then in 1938, 1942, you can see we're getting closer and closer to the actual peripheral portion of the continent, and this was the continent of Antarctica, known in 1937 with Dumont d'Urville and through the 1841 period. Then the first IPY. There is a series of IPY years. There's 1 and 2, then there's a superimposed IPY quasi-3, which is the International Geophysical Year and the current International Polar Year. The first IPY was 1882 to 1883, so this awareness of an International Polar Year isn't something new. We've gone through it before, and it was 12 nations, and they launched 15 expeditions, 13 basically in the Arctic, because there was a way and a knowledge to get there. There was a transportation system that was proven, as opposed to going to some place where man had never been before. And 2 Antarctic expeditions that basically went around the periphery of the continent. What was important for the U.S., it established our northernmost scientific research facility at Point Barrow, Alaska, as part of this effort. Then the Borchgrevink actually landed. It was a Norwegian expedition. They actually landed and wintered over in Antarctica. What do I have is in the 1985 window. So now we're approaching the turn of the century, and people are actually reaching the continent. They're stepping foot on the continent, and they're wintering over. Then came the race to the pole, the famous Roald Amundsen and Robert Falcon Scott. And they started out from 2 different locations. Basically, Amundsen was on the left of the Ross Ice Shelf, and Scott was on the right, which is an island, Ross Island. And all of these locations are, the origin, demarcation is from New Zealand and then south to the ice. That's the shortest distance. Amundsen succeeded and arrived at South Pole on December 14th, 1911, spent a couple of days and raced back to his ship and went on back to Norway. Behind him, lagging a bit, was Robert Falcon Scott, arrived on January 18th, 1912, a month later, and realized that they had been beaten in terms of the race to the South Pole. But as the records show, he spent a little bit more time collecting scientific research samples along the way, and he used some methods of transportation that weren't working out quite as well, and there was also the coldest march known to man on his way home, and he and his team did not survive. Right after that, there was the Ernest Shackleton, the Endurance. Shackleton's voyage trying to find themselves on the Ronnie Ice Shelf and coming across the continent, and their ship was locked into ice. It was crushed by the ice, and this was the epic, heroic effort of Shackleton going to Elephant Island and back, and coming back and rescuing his entire crew. What was interesting about that crew of, I think it was 20-some men, or maybe more, they all survived after a year and a half to 2 years. A good portion of them then went back and served in World War I. and 3 of them lost their lives in World War I after surviving this. The next visitor to what we call home, 90 degrees south, was Admiral Byrd, and he was the first person to fly over South Pole on November 29th, 1929. He flew over and he dropped an American flag over what he had calculated as being 90 degrees south. International Polar Year 2 was 1933 to 1934, and it was 44 nations, and it now represented ionospheric physics, radio sounds. As you can see, the level of sophistication, the level of scientific research is improving based on knowledge and the ability to get into the continent and the interior. Then, what I call the quasi-international Polar Year 3 was the International Geophysical Year, known as IGY. That particular program for the United States established Little America 5, Byrd Station, Ellsworth, Wilkes, Hallett, and the South Pole Station. It was the first time that man had ever set foot at the South Pole and spent any length of time, and built a scientific research facility and actually wintered over in 1956 and 57, not knowing what the conditions were going to be like. And it provided a support runway, which we currently know as McMurdo and Williams Field. That was the logo, and it truly was a time, also a time of sunspots, and it, again, was truly an 18-month window of time where, again, on the Ross Island, the United States brought ships in, and the first camp, the first station at McMurdo was built by United States Navy Seabees, and they were an elite team of construction personnel and support personnel that landed on the ice shelf, tractor trained across, set up a tent city here at the nose of McMurdo, and then built a city which is currently still named McMurdo. So the evolution of South Pole now begins with Amundsen's tent. That was the first South Pole station. Then the Navy built their research facility in '56, and as Tom mentioned, the South Pole Station, the dome was built in the '75 period of time, and I'll walk through the need for a fourth scientific research facility, which is the one that's currently built and commissioned. So the first station, we'll now walk through South Pole. The first station built, I'm going to say it was a 1911 structure built by the Norwegians. It was on surface, it was low cost, and it was a prefabricated structure. So meeting the budget probably wasn't a challenge. The actual Seabees weren't sure how they were going to get to South Pole, with the exception they knew that at that point in time, R-4D aircraft were available at McMurdo, and the Navy put together a team and said, what we're going to do is we're going to fly up the pole, you're going to land at the geographic South Pole, you're going to keep the engines running, you're going to understand the density of the snow, you're going to get out, take some pictures, do some weather samples, and fly on back. And Gus Shin is still alive, and we've talked with him because this happened on the 31st in 1956. So in '96, it was the 50th anniversary, and so we went down and it was a celebration. And the senior management at NSF asked Gus, he said, what was your backup plan? Because there was no support except for a couple airplanes flying over the top, but they didn't have skis. So these folks were on their own and said, we'll volunteer. His response was, we didn't have one. And that's, once the aircraft returned to McMurdo, within a couple of weeks, the team that had wintered over at McMurdo and built that station, 24 Navy Seabees on multiple planes, flights on that Que Sera Sera, flew in. They basically told them to jump out the side door, and they set up some tents, and then over a course of 2-3 weeks, these aircraft dropped the construction materials in for them, and in many cases, the materials landed 8 to 10 miles away. And remember, these individuals were at sea level, and at South Pole, you're at 9,300 feet of ice and 10,000 to 11 or 11.5 barometric pressure, minus 23, 24 below 0 Fahrenheit. With the wind chill, it can be minus 56. And there they are by themselves, having to dig this stuff out of the snow and build a station, and that they did. With the U.S. flag here, true U.S. ingenuity and military ability to get something done, can-do Seabees. But it was prefabricated panels and then a stick frame connector link, recognizing that Mother Nature would cover it up. But the key here was to build something that was a city of 18 men, and here are the 18 men and one dog, and it was broken down to 9 scientists and 9 U.S. Navy support personnel. And that was the balance. The station operations, handling the power plant, handling the food service, was the United States Navy, thusly allowing the scientists to perform scientific research. But the research, well, before we get to that, that evolved as a result of the success of that particular period of time. The United States having our stations, there were 11 other nations that were part of the International Geophysical Year. That brought forth the Antarctic Treaty, which declared and specified that the continent was a continent for scientific research only, and that it was not to be used for military gains, mineral exploitation, or for any gains of ownership of the continent. It was a continent for science only. And today, we have the ceremonial pole in the front of the station, and it represents those 12 nations. In addition to that, there are 28 voting nations. So they're from the 12, we've gone to 28, and there are 17 non-voting nations. And these nations are actually actively involved with building research facilities in the proximity of their home countries on the continent. So we're seeing more and more individuals involved with scientific research. With that does come some issues with a little bit of change of policy over the years. These 1, 2, 3, 4, 5, 6, 7 countries have indicated compliance with the Antarctic Treaty, but have indicated that they have reserved the right to establish what they call territorial claims. The United States does not stated a territorial claim, and these are basically territorial claims only, but you can see that their wedges, their sectors come within the proximity of their country from the bottom of the planet Earth. That 57 station, the IGY station, there's the American flag, and that station, built on a surface in 56, 57, over the years, succumbed to Mother Nature. Mother Nature has a tendency to want to, regardless of how tall the building is or where it is on that plateau, it'll cover it over, and then it'll level it out for hundreds of miles, and you'll never see it again. In this case, what was interesting is we really didn't have a plan to continue scientific research because we really weren't sure what type of experiments made good sense at the South Pole. We weren't even sure if those team of 18 men were going to survive or not. Well, they did, and each year we kept coming back with more scientists, more sophisticated, upgraded scientific research projects. Mother Nature came along with us also and started to build up around the station, over the station, buried the station, and here you can see we actually have a tunnel that gets down into the station to a point where the crushing of the station and trying to reinforce it on the interior was no longer feasible, and we realized that technology was changing, and we're starting to understand some of the things that Delaware is doing now, and the astronomy, astrophysics, and the global warming and climate monitoring. This was the place to do it. So we moved. As we went through the seasons, this station became crushed, and in 1969, a set of drawings was completed and signed off by the United States Navy, and the Navy at this point in time was still the military support entity that was flying the aircraft in, flying the support personnel in, and in essence the stations were U.S. Navy-run stations supporting science. That changed in 1969-70, but before that, the Navy was still involved with the design of the station, and they brought in Navy Seabees in 73 and 74, boots on the ground again while the other folks who were living subsurface, and built what we call this state-of-the-art geodesic dome, which housed 3 two-story facilities inside: science, food service, communication, and housing and that sort of thing, and a network of 850 feet of arches which had fuel storage, the medical facility, it had the power plant, and the garage shop. That station was dedicated, and that's myself there in 1974-75. We had to live in Jamesways that still say, and we're still using today, it's a canvas-covered Quonset hut that's 16 feet in diameter in sections of 4 foot wide that you can fold up because you can put them on the bottom of a helicopter. These are the same units that were used in the MASH units in Korea. So when you see the movie MASH, this is what you see, and the veterans out here know that at Pole, those still say U.S. Army on them, and they were open bay barracks back in the day, and you had a pre-way heater in it, and you had a double bunk. And again, that was back in the days when I said 18 men. Everything was men, because it was unheard of to have a female on the ice, and you know, female PhDs and scientists and science support personnel hadn't really been accepted at that point in time. This is what the inside of the dome, veteran winter over, what it looks like. Well, it did look like, and again, these are the 3 two-story buildings. The dome did not have any structural design integrity. It was not intended to carry any loads, only an environmental envelope that allowed people to function from building to building inside at ambient temperature. So when you walk from one building to the next, it was subject to the heat provided by human beings, and as we had dozers running back and forth, it was at least 45 below zero or more as you walked back and forth. That also was part of the design so that there was no, Mother Nature, if it warms up, wants to bring that floor up, and it would start to crush the buildings to the top. The current 4th International Polar Year, and there's really a typo there, my apologies, that's 07 to 09, is underway, and it has 200 projects are planned involving 50,000 people and from 60 countries. And the key research areas are, again, is to engage in the understanding of polar regions, and I think that first sentence, and in the global system, and advancing our nation's general science literacy, especially Antarctica as it relates to that volume of ice and what's happening with the human presence on the planet Earth. I think there are a lot of things that we can learn from that. And when you look at the continent and realize that as large as it is, you have South Pole, which could be in Newark, and then the next scientific research facility could be in Madison, Wisconsin. There is so much of that continent that we haven't had a chance to explore or look at just because of the logistics and the corresponding expense. Okay, the United States has, as I mentioned, 3 year-round scientific, can you see, folks? Okay, research facilities on the continent. And again, this is the continent, and as you talk about sea level, and then you get up to South Pole, this is the delta between sea level and that 9,300 feet. And you can see that there's a transantarctic mountain range here, and this entire block is ice. And here, it's 9,300 feet. That's rough order of magnitude, easy math. That's 2 miles. And out in here, it exceeds that. And it's a year-round facility, and it's basically the hub for us at South Pole. All the materials come in here, then they have to be flown up to here, scientific and construction. No different than support of scientific research in the interior portions of the continent. The other station is up what we call a banana belt, and this is South America, and it's not as many degrees south. It's a smaller station. You can tell by the topography and the lack of a lot of ice, with the exception in the background. Again, it's 40 or 64 degrees south, and it has 40-some people in the summer and 23 in the winter. That is served, as you'll see a little bit later, from South America. The crown jewel, for those of us who spend a lot of our life at this location, is South Pole Station, and it's up on the plateau, and there's a picture of the dome and the entrance of the dome, which is now non-existent, but it's 90 degrees south latitude, and the personnel, right now we're supporting 260 people in the summer, and in the range we were supporting 80-some, which included construction. We also have 2 research vessels, the Gould and the Palmer, and they circumnavigate the continent performing scientific research as it relates to the oceans. The National Science Foundation is really an organization. We're a federal agency funded within the independent group of HUD and VA. We're located in Arlington, Virginia, and we have a yearly budget in the range of $6 billion, and we have these directorates, of which one small piece over to the right is the Office of Polar Programs. And just real quickly, the Office of Polar Programs represents the Arctic as well as Antarctica. And our budget within that $6 billion is in the range of $350 million. So we have a small piece of the pie, with the exception of special projects receive different color of money, such as the new station. And the Arctic program has $100 million. We work in partnership per a directive of the President of the United States with other countries, New Zealand, Chile, other federal agencies, NASA, NOAA, USGS, regulatory agencies in terms of protocol and compliance with environmental issues, and the Department of Defense and the Coast Guard. The Air National Guard, the military still flies the aircraft. And here you can see from Washington, D.C., we fly to Los Angeles down to Christchurch, to McMurdo, and then up to Pole. Palmer, near that banana belt as we call it, they're supported out of Santiago and Punta Arenas. Here's some of the transport components that get us to the Antarctic, get the materials we need to the ice: aircraft, helicopters, icebreakers, and ships that bring in fuel and bring in materials. Each year we have to bring a tanker in just for the fuel for the station power plant and for the aircraft to fly missions back and forth. That ship, when it comes off the Ross Sea into the Ross ice shelf area approaching McMurdo, the ice at the end of the season may or may not be broken out, and we have to solicit the assistance of the United States Coast Guard cutters to come in and break a channel that can be 5-6 miles out that will allow 2 lanes of traffic for ships to come in. And once that channel is broken out and this area is churned up, you can see how that's churned up, then we bring in the tanker, and the tanker comes in, and they offload in the range of 6-7 million gallons of fuel that's stored at McMurdo that we use for the following season operations. When that is completed, that ship goes back out, and waiting at that channel entrance is our resupply vessel. And the resupply vessel comes in with 10 to 11 million pounds of materials, which is everything from computer repairs, a mouse, to construction materials, to ice top tanks, to DOMs, to cables for the Ice Cube project and for the construction of the new station. And per the Antarctic Treaty, we have to take everything out of Antarctica as part of a waste stream. We've been thinking green some time ago, and so everything is source segregated at South Pole in the range of 15 to 20 different elements, with the exception. And then it's backloaded to include McMurdo, and we take another 9 million pounds of materials back to Washington State, and those materials then are either melted down or sold as copper or aluminum. The second category is materials that can be burned for kW and power within the United States, and the third category would be things that become landfill. With the exception at South Pole, because of the human risk and the cost, we do not take out human waste, liquids and solids. We do not take out the waste from the garbage disposal in the dishwasher and the liquid from the shower. I'll show you a system where we flush that into a system that takes it 3,000 feet from the station, and we have these cavities, and we drop it into those cavities, and when it fills up, we swing the discharge line to another location. We survey where it is so we know what's there, and then it freezes. These are the icebreakers, and we've reached a point where we've actually had to solicit additional help from the Russian government. The Krasen is the Krasens on the left, and the Swedes, the Odin on the right, which also serves as a dual function as a scientific research icebreaker, projects which are funded through the National Science Foundation. As Tom mentioned, I started with the support contractor in 1969, and I began living the dream in '69 as a laborer at Byrd Station. This was Byrd Station, another station that was buried, and the cycle has allowed me to go back to South Pole and dedicate the dome in '74, '75, and then be the NSF rep and construction project manager for this new station in the last 15 years. And so from start one to this year is 40 years of being a cycle of starting and completing in a project, and Tom mentioned in the range of 5 years of spending time on the ice. And that is a picture of the station, the elevated portion completed. And so real quickly, it all started in a one-room school, which had one teacher, 13 students in 8 grades, and this guy here that started to realize that he wanted to travel around the world, was enamored with Admiral Byrd, and it sparked a dream to go where man or a few people had gone before and be able to join this elite group of people that I see out here. I tell people that when we built the station, Genois was talking about how he remembered me in '94. Early in the morning, we were going over drawings on the kitchen table in the galley, and we realized we needed an office, and there wasn't money in the budget, so we basically found some surplus buildings. We put them together, and we had a wall between it where the NSF rep and NSF discussions could be handled on one side and the contractor engineering on the other side. And you know, that evolved to having actually a VoIP VoIP system, a copier machine, digital photography. We didn't have any of that in the early 1996, 97 window. But what was interesting is this was the NSF rep's office, a prestigious title and a prestigious office with a window. I actually had a window there, okay, to look outside. The name Cheese Palace was provided because my heritage being from Wisconsin, a couple of the guys said, we have to name it the Cheese Palace. And so it became the Cheese Palace. And each year when I arrived, I would put the American flag up. And then when we completed the season, take the American flag down. And I always had my University of Wisconsin pennant there, and a cheesehead hat, and a Green Bay Packer flag. Okay? But the early science at South Pole, as it moved from IGY, evolved to, for example, climate monitoring and global change. This was one of the first, it's actually the second, but early clean air facilities. We thought we were really sophisticated engineers. Another individual, Frank Breyer, and myself had our names on this set of drawings. It was a plywood building on the surface, but it maintained a continuous record that's still in place from 1956, 57 winter on all of the ozone, all of the sulfides, all of the fluorocarbons, everything that is chlorides is now, it's a baseline. And so the questions in terms of what's happening, one can go back to those. And this here is and I hope I have the title correct. And this was at South Pole, and help me on what year this would have been, Tom?
About 1968.
And Lynn?
Oh, I think that's
Or what?
85.
Okay. No different than the original station built. I mean, it was very rudimentary, primitive scientific research. And this was the seismometer, and this was the seismic research, and it was basically a box that was 1,000 feet from the station in a tunnel below the surface, and that was the beginning of research. This was Dr. Paul Seipel and Lieutenant Tuck. This is the military and the scientific winter overs, and this was using a theodolite, and you can see how basic that was and primitive. Today, it's a big city. We actually have sectors, and the sectors include the station operations, and we've learned from Dr. Paul Seipel in his book from 56, 57, he had the vision to say, if we're going to perform scientific research at a location where man hasn't been before, we need to have zoning. I think it was the first zoning in Antarctica. We need to define areas so that we're not in conflict with each other, but yet allow ourselves to grow in terms of the expansion and the technology. We've continued that, and we have, for example, our operations sector, and you can see the station, the runway. The quiet sector has earth science projects and has seismic projects. In the upper right-hand corner is the clean air project, because it is in a vector that has a wedge that's almost 2,500 miles towards Australia that has virtually zero influence on human presence on the planet Earth, because there's no one out there. So it's basically the cleanest air on the planet Earth. So we have some really good data to draw from. And then the dark sector sends a light for the Ice Cube project, the South Pole Telescope, and the Martin A. Pomerantz building is located there. And these are a bit busy, but this is that was the atmospheric research facility, and I was talking about the carbon dioxide, the aerosols, and the ozone depleting components, the CFCs and the HCFCs. All of this has a baseline. It's a 2-story building. It was built up on a berm, and it's occupied summer and winter. And at some point in time, we'll have to raise that particular building and probably expand it. But that is in the clean air sector. The station itself has food service. It has housing, it has communications and medical, and it also has science in this B2 science lab, and these are some of the experiments that are being conducted there, as well as it also has the office for the Ice Cube and the Ice Top project. In the range of 8K from the station, or 10 miles, we have sensitive. We have a seismic location, which is much more sophisticated than what was there in '56. And again, the dark sector lab and the Martin A. Pomerantz facility with telescopes. And there's a picture of Dr. John Lynch, who was the NSF science rep and PI for the project. And this was the dedication of the Martin A. Pomerantz building, with that plaque being put on that building with the ceremony, and it was a true honor. I was there with him that day. It was so cold, as Len and we were talking about. We stood out there, but that was a true honor for myself to be part of that. And this is another scientific research facility, the 10-meter telescope. What we say, those of us from Wisconsin are good friends from University of Chicago. So the level of sophistication and the magnitude of planning and construction has grown appreciably. And here are some of the results in terms of the dark energy, understanding galaxies. And that takes us to the Ice Cube project, which on the, must be a timer. Am I running out of time? Okay. Is the project started with 1 string. The goal was 80 strings at 2,400 meters. Each string would have 60 digital optical modules to include 2 each ice top tanks. And as of this year, this particular season, we reached a new all-time goal with 19 strings, and we'll finish the project either next year or the following year. And it's a project that has reached its goal in terms of production and budget and schedule. Real quickly, the new station. In 1997, we realized that science was expanding so quickly, and the fact that technology was expanding so quickly that the population at Pole was no longer code compliant, and we had heard rumors within the science community that it wasn't going to be long before some big projects were coming our way, and we needed to have a platform to support that science. And so we embarked on designing, keeping these sectors, but designing a facility that would support 21st century science to include the challenges of our transport vehicle from McMurdo to Pole is no different than a space shuttle. Every bit of 25 million pounds that put the station together over 12 seasons, summer and winter, had to be designed to maximize not exceeding 26,000 pounds in that aircraft, not exceeding the length, the width, and the height, not exceeding the pieces of equipment we had. This is one of 45 10,000-gallon tanks for the new power plant. When finished, the coordination was with the Air National Guard and the loadmasters. The chains, from the chains to the fuselage, was a ½ an inch. That's how tight we scheduled everything. On the bottom is one of the saddle trusses. It was 40-some feet long, 48, and so it exceeded the weight, in the length, so we had to have a splice between it, which represented 110 bolt holes. So we had to ensure that we fabricated it in the States so that we could put it together at minus 40, minus 45, below zero during the summer in 92 days per season. The project represents in the range of $175 million, and it's designed for 150 people in the summer and 50 people in the winter. The goal was, Congress indicated, there was a lot of meetings in terms of how big the station should be. Congress gave us the money initially for 110 beds and said, when you're finished, you hang the "We're open for business" sign outside, and those big science projects come in, then we'll give you the money for the other 40 beds. It was the year 2000, 2001. Ice Cube was on the horizon, the 10-meter. We received the money. This project was completed. We were told within the engineering construction discipline that we needed to insert these two projects into a construction schedule that had zero contingency for money, zero contingency basically for time, and zero contingency in terms of a lot of changes such as two large projects. The project, when it's finished, will be next year, will be in the range of that number, and with the ads, there's been some ads, we will be in the range of maybe I'm going to use easy math, 10% added cost, which is unprecedented for those having those constraints and building in the conditions that we are, even if it was done in the U.S. And as we mentioned at lunch today, it was one tremendous amount of partnering and planning between NSF and the science community in terms of how to insert these projects and make them work and understand what the science community, what Delaware, University of Wisconsin really wanted as a station. We had to sequentially build the subsurface, which is the fuel storage, garage shop, warehouse, power plant, excavate, and take each one of these components each season. In 110 days, we only had 92 work days, and the temperatures were such that we had to choreograph each season so that we did the outside work and closed it so the construction people could work inside so we could come back and sign off the conditions, not to mention so we can transfer the functions from the dome and in those areas and not miss a heartbeat on keeping the station running and supporting additional science. Again, it's going to be in a range of 925 LC-130 flights, 25 million pounds, and I'll go quickly. This is what we do and we work with. You can see Ice Cubes up there, UChicago. In the heyday, the government will allow so many missions based on other commitments in the United States of LC-130s to include 2 wars at this point in time, Afghanistan, Iraq, and other military commitments. So we received, out of 410 flights, we received the lion's share. We were up to 350. Each of those, it can represent 9 million pounds of materials. With 15 actual work weeks, 16, we had to choreograph and plan each pound per week, per flight, to ensure that every project received everything sequentially as they needed. And we're still doing that. The minute that we're off by 2 or 3 flights that we're on station, we get a friendly visit and knock on the door from our good friends at Delaware and Ice Top. What's happening with our Ice Top tanks? Where are they? You know, because everyone's watching these schedules so closely, there is no room for it not to happen. Not every day is a perfect day at South Pole, summer and winter, and I'm just going to go through this. Here's the change out of the old technology of fuel bladders to fuel storage tanks. Here again, we're building the frames of the garage shop, enclosing it so they can work inside. This is the old garage shop. This is the new. This is the power plant. We had lost a year because of bad weather, so we had to build the arch in the building. There's the old power plant. That was all built in one winter, I mean. The old method of water sewer under the station. This is a 3,000-foot tunnel. The subsurface is completed. Here's the pad for the elevated station. This is the test assembly at Little Rock, Arkansas. We found that those splice joints were off a ½ an inch. At plus 100, it was a lot easier to fix them there than minus 50, 60. And here you can see we're trying to sequentially put these blocks together so that it's closed up on February 15th, and then you can transition food service to the new food service and then leapfrog to the next component. Here's the old housing, the new housing inside the station. It's just like a university dorm. And here you can see we're starting to move along, and these previous wings have been accepted and occupied. And we have one wing that's entirely redundant wing. The entire station can burn, and we can have our folks survive in that in the winter. There's the medical facility, the new, and here's the depressing news is all of us that have lived there, especially winter over, demolition, old comms, the new communications state-of-the-art, and dedication, January 12th. Major, major accomplishment. What was finished this year was the logistics facility. Sarap, you were talking about what does it look like when it's finished. And so what's remaining next year is the disposition of the dome, which is demolition. The project will be finished in the year 2010. And we're currently in a rebid for the Antarctic support contractor with public bids due in next week. And we have new communications in support of the demand from science, specifically connectivity back to the States. And again, you can see, if you want to get into the megabytes, Ice Cube, other science, and South Pole Telescope, where the science community is there, and their demand for transfer of data and having it back quickly for analysis is becoming another challenge for us. And we've been currently using junk satellites because of the cost effectiveness and the ability to have them available. We've been thinking green for some time, operational efficiencies. We take heat off the engine jackets, warm water, pump it out 3,000 feet, form a cavity that's 350 feet down, 100 feet in diameter, or 75 feet, and then let it melt with water until it reaches a point where it won't saturate into the walls of the ice, and that represents 1 million gallons of water, and that's where we get our potable water. We do not have to burn, we don't have to send it through a melter, which means we don't have to ship up fuel, burn fuel to generate our water source. When that bulb is drawn down based on the population, then that becomes the sewer bulb. Now, we have them already marked out so that there's no, okay. The future is South Pole. It will be 21st century, the Ice Cube project, the Ice Top project, the 10-meter telescope, and additional advancements to those projects, without a doubt. But we're also finding that we're becoming a hub of science. Traverses are coming our way. We're now thinking of ways to reduce the number of LC-130 flights. At 3,000 gallons of flight, we need 200 and some flights alone. They're just tanker flights. It would be more cost-effective for the U.S. taxpayer if we could take those flights and take them to the interior of the continent and land them in open field areas where we haven't conducted science before, and have a traverse bring fuel up to us. So we're looking at that. We also, and here's this year, the proof of concept showed that we were bringing fuel bladders at 3,000 gallons per bladder. They drove in and they drained them down, and they went, and hopefully we'll have the system proven where we can load up retrograde and take things back down the haul road as opposed to putting them back on aircraft. International Polar Year and other countries are joint venturing with the U.S. or by themselves, and as they explore the interior of the continent, they use and are using South Pole as a hub to stop off, and we can support them based on memorandums of agreement, or if they, it's a place for them to find additional fuel or additional support in terms of supplies. So we are truly a hub, and these are, when you talk about these traverses, you get an idea of the tractors, the sleds, and the trailers. So there's a lot of thought in terms of how to make these efficient. Not to mention that the interior of the continent, for other scientific research that's going on here and here, is supported out of McMurdo. But you can see here this last year how we supported projects on the interior. So the future of South Pole is truly going to support the east and west Antarctic plateaus. My apologies, fast questions. How'd I do, Tom? We're fairly close. Okay, I'm sorry for how fast it went. Good. Okay. Questions, please. No? No, okay, Glenn.
Are there any plans for a 100th anniversary of the Amundsen arrival?
1911 to 2011. The answer is NSF is thinking about that? Definitely, yeah. And what that will be, I'm sure it'll be an option that will be is with the Norwegians and the U.S. Yep. Yep. Actually, that will also be the 100th anniversary in 2012 of Scott. So both of those will coincide as being 1 year in the next year. No question about that. Yeah, because we had a recognition of the 50th anniversary of the first flight that landed, Que Sera Sera, and we also had a recognition of those Seabees that built the first station. They actually left on January 4th, 1957, so we actually provided a certificate and an American flag to each and every one of the survivors of that team and mailed it home and said thank you, as well as the first winter over team. So discussions are underway, Len. Yep. Yes?
The new building appears to be built on pilings. Are they sunk down into or how are they put together?
The very good question. The length of that station is in the range of 410 feet, and each one of those wings is in the range of, when you add the front portions, is 75 to 80 feet, maybe more. There are 32 vertical columns, and they're set. There's we've excavated the snow down 6 feet. We churned the snow. We walked it with the dozer 180 degrees. We've created basically a domino pad, and because of the density of the ice, or the snow under us and then the ice, is that basically floats, if you will. Therefore, we can't pour concrete, or it would be extremely difficult, is that we basically have 2x12 members, 3/4 inch plywood, which is a box frame mat footing, and then we have grade beam steel on top of that, and then those columns come up off of grade, and they're in the range of 12 feet before you get to the base of the station, depending upon where you're standing. And the intent is, with that chamfered front, the basis of design faces it into prevailing winds, and the wind tunnel computer analysis indicated that would then create a small drift in front, and the eddy would come up over it, and then the chamfer would accelerate the speed and shoot the snow underneath the station and take it downwind and deposit it. And that if the computer model was accurate and the station was finished and there was nothing downwind and nothing to negate that in the front, that drift would build up, yes, and then in the range of 15 years, Mother Nature would then start to build up the base from grade up to the soffit, and then one would have to then raise the station. And that we test assembled, and we also experimented in Little Rock, Arkansas, with raising the facility. We only did one column, so the jury's still out if we truly can raise the entire station, but the computer model shows that we can, and that in 15 years, let's say, we would then, one summer activity would be to move that station up 15 feet and put in the range of, it's actually 12 feet, 2 6-foot columns under sections, insert those under each one of those 32 points. And then the station sets, and then the process would repeat itself. And there was a thought that maybe, that gives you 30 years of design life, that possibly it could go beyond that. We all recognize science will change, and technology will change, codes and standards will change, and the infrastructure may have exceeded its design life. Yes?
Old dome, is it going to be a museum somewhere?
They don't.
Can you repeat the question?
It's a very interesting question, because the current budget and basis of design was that the dome would be disassembled for scrap, which meant that the dome would be taken down in the best interest of the taxpayer as efficiently, effectively, and safely as possible, boxed up, if you will, sent back to Washington State, and melted down. Over the last 5-10 years, there's been interest, and NSF is still pursuing it at this date. Reason being is that next year is the last year of the project, is that the United States Navy and Navy Seabees and Historical Foundation have voiced various interests in NSF's consideration to disassemble the dome for reassembly. And from there you have to stop, and you have to have a lot more discussions on what all that really means and how we're going to do that, maintain the schedule, and maintain the budget. So the jury's still out on what will happen to the dome, but the official budget scope of work is that it's scheduled for demolition as scrap.
There'd be a bigger revenue stream if they had a museum. It'd be forever. People would buy tickets to see it.
It comes with a lot of questions in terms of footprint of people to take it apart, And is taking it apart for reassembly going to take more pieces of equipment? Is it going to take more labor? And all that impacts an already full 1 to 2 to 3 seasons in front of us, and that would jeopardize the momentum and the success of IceCube, or it may. I'm not going to say it will. And we also are starting to build the base ring and the shield around the 10-meter telescope, which will take 2 complete summer seasons.
Well, I'll volunteer. I wintered in that dome.
You did?
1981, yeah. So you could get volunteers to help take it apart.
Well, then if there are any questions regarding the dome, I have 2 winter over experts here. Well, then, geez. Okay, we'll have to talk. Okay. Other questions? Yes, Tracy.
There are a couple of questions from viewers in Second Life. And the first one is, curious what activities take place in this facility over the winter months?
Well, what I'd like to do is I'm going to defer to 2 of the winter over veterans here who lived in the dome, and then maybe I can add to what folks are doing today in the 21st century in the new station. So if I can defer to these 2 individuals. Is that okay?
Well, we watch a lot of movies. A lot of what we did was watch movies. I remember there were 17 movies on 8mm or 16mm movies, the old-fashioned reels. This was 80, 81. And the big thing was who's going to get up and change the reel, because it would sit there and flap. We would be in the bar. Tom, you know all of this. And so we watched like Coal Miner's Daughter, I think, 118 times. There was a chalkboard. There was a lot of the activity was reading. People would learn foreign languages. They'd take courses. There were only 17 of us my year. So, I used to go out and take walks out at night and look at the stars in the Aurora Australis. It was just gorgeous. Just felt like you were in deep space. It was so dark. Did you have anything?
Chinua?
Well, that's basically what
Yeah.
we did.
Same thing. What year did you winter?
That year we had like 4,000 videos there. Wow. It's a lot more.
Well, you had the videos.
Yeah. I think that's all I want to know.
The other question from Second Life, is research reduced through the winter months due to the severity of the cold or the constant darkness, or both?
Again, I'd like to defer to the science community here, but just as a general,
That really depends on
right.
What science you are doing. For example, for us, IceCube, actually the winter time is the time we take the quality data. For the summertime, we do the construction and we calibrate the array and so on. And for other projects like Astro, I think if they use optical wavelengths, I think winter is another. Actually, it might be a problem because you don't have this visible light. For example, if you study the sun, then it's a problem.
Any other questions? Yes?
I know that some of the researchers from Delaware have geographic features named after them on the continent. Do you have such features?
I'm very fortunate and blessed that I do. Yes, it's Marty Nunatax. It's 85 south and 155 east, and it's a series of mountain peaks. Nunatax is a mountain formation that's basically protruding through the ice, and there's an ice flow around it, and there are 5 peaks in a row. And the answer is yes. Thank you. Yes?
Well, I have questions as a tradesperson, as like what changes in extreme temperatures as far as like nuts and bolts, welding, maintaining vehicles, stuff like that. Obviously it's way different, and there are some serious challenges.
On our 955, the H-frame cracked in the winter. It was
Well,
about
I'm
90
sure.
below zero, and it just cracked. So we had to weld it. That was really.
But I'm sure that gets a lot more difficult, just like working at the space station.
A good point, and probably the most severe element that receives the most difficult challenges are human beings. Not to mention the equipment. The equipment we've learned from your lessons and some of the challenges is that we open the station basically at the end of October and we have pretty much a full complement of our people, which includes the operations and the trades personnel on around the 1st of November. But we really can't move into total operational support and or construction until on or around the 15th of November, because that's when we reach the magic temperature of being at -40 and above, where the hydraulic lines, the gear systems and the transmissions and the steel has an opportunity to survive. We've tried to push it before that, and we find ourselves with these pieces of equipment in the shop all the time. No different that at the end of the season we have to schedule when it's time to terminate projects so that we have the equipment to move things around before it gets too cold and we can't operate cranes at a safe, within a safe margin. Humans, that's the real challenge. Is the issue is to design something that you drop a through bolt through it. It's got a big nut on the back, and then basically the construction crew actually had these little we call them Smurf shacks, these little plywood ticky-tack buildings along the construction chain in site. And the lead person was responsible to be a carpenter, iron worker, IT guy. Is that if it's, give yourself 50 minutes, and if it's cold and it's windy, come on in, let's get some hot chocolate, let's get some peanut butter, and change out the gloves, get them dry, and the socks, and go back out. The challenge is the pieces of equipment, the temperatures, and the cold temperatures. Any others? Tracy?
There's one more from another viewer in Second Life who wants to know, do you have internet connections down there?
Yes, we do. And that as the veterans here, different than back in the 80s, is we have internet connection, but we are satellite dependent. And we are using what we call we're recycling current satellites, and they are parked in an orbit just above the equator, and they wobble, so they're in a geosynchronous orbit that allows them to drop below the equator 8 degrees, and we're so far south that 8-degree window is the only window that we can see them. And we've basically had a series of 3 that we would overlap, and that series gave us 12 to 14 hours of connectivity only per day. And now we just lost one, and so we basically have 9 this year, compounded with the fact that we use New Zealand time. And we use New Zealand time, which is from Washington, well, from the East Coast, plus 18 hours, so that all military aircraft schedules from Christchurch to McMurdo and Pole, pilots and anyone associated with aircraft operations do not have to make any conversions. That's the safety value. So if you're in Washington, D.C., if you're in South Pole, and we are at the Cheese Palace, and we have an engineering problem that isn't going to work, and we need to have a decision with providing options, and it's a Sunday. If it's a Sunday, it's a Saturday in the States, and if it's at the right time, we have to wait that window of time until the satellite comes up, and then we may not find anybody at home. So over the period of time, now we have cell phones. We don't use the cell phones, but we're able to dial in cell phones, and the internet will now allow us to take general data and send it out. So we can call from South Pole. We can ask Tom, Len, Sarap, we have a problem on something on ice top. Can you get back to us? And then we also have Iridium, so there's a backup. The answer is yes, but it does have some complexities in terms of that window of time, which became a true challenge of the last 12 years of building that station, because early on, without Iridium and without the cell phone and this link of data, just data transmission, when we had a problem on station, we were in a holding pattern. And that holding pattern clicked off by hours against a percentage of the time we had to finish the project. The internet also allows you to send digital photos. So if there's an engineering challenge, we can photograph multiple images of the problem. We can scan the drawings and say, here's the detail. We then can provide multiple options for consideration as a solution and list of pros and cons, and they have it in the office immediately. But that's only been in the last 5 years. Good question. Yes?
Have you personally witnessed any evidence of global warming in your travels over the years?
Okay, I'm going to defer to some of our veterans here. Is that, okay?
I got a picture
Yep.
of McMurdo. Got a picture of McMurdo in 1979, and James took one just last year, and we had the two slides. I think Tom digitized them for us, but you can see it was taken at the same date, and there's a lot less snow at McMurdo at that date, and the glaciers right there. So there's one right there, one example.
I defer to Chinwal, these other folks, the veterans here. Over the last, let's say, 15, 16 years, experiences on seeing some warmer temperatures during the summer or not? No? No? Okay.
Also, the atmospheric temperature does not change that much. Does not.
Okay.
Palmer it did. I've wintered at Palmer also, and it's changed a lot in Palmer.
Mm-hmm. Mm-hmm.
A lot of giant chunks of ice are just deteriorating and falling off.
Which we don't experience and we can't trace because there's no bench line, because as far as our eye can see on the horizon, 5-6 miles, 360 degrees of vision, it's pure white, and we have 9,300 feet below us. The only thing we could probably track is if on a given day, on our warmest day of the year, which is the middle of December, over the last 20, 30 years, have we seen temperatures that have gone above what is considered the highest, the warmest temperature. And I think we actually had 1 or 2 summers where we went above that by,
January 12th,
right here?
2006, it reached, what was it? Above zero, basically. It was 12F.
Yeah, yeah,
12F.
yeah.
Sorry?
Was that the record high?
It was not the record high. Record high was 1964 or something. It was also 13F for the same day. So it was not a record.
Yeah.
But it was a glitch.
Glitch. Any other questions? Yes.
How much orientation do you have to go through for new staff that are going to be there in Antarctica, like for the cold weather gear and safety and all that? Is there an extensive program to get people ready to go down to Antarctica?
The National Science Foundation support contractor is responsible for the indoctrination and the advisement and the training and awareness for all of the support personnel that would be, as I mentioned, the doctor, through the cooks, the vehicle operators, the mechanics, the construction personnel, etc. And they bring folks into Denver, Colorado, or wherever their home office may be based on the term of the contract, and provide them with that information. Today it's all online. We're finding that, well, in the past, a high percentile of the people hired were referrals, and so there was a lot of discussion from one person to the next of what they were going to experience, and so it was, some of it was word of the mouth, but there are specific topics of discussion in terms of what you're going to experience, what you need to be aware of as you make a final decision to go to Antarctica, which includes living conditions, the term of the contract, and the number of hours you're going to work per week, and the environment, and your community, which will include scientists, PhDs. It'll include working with the military, people in uniform on that aircraft, working with people in communications that are going to be very structured in terms of how they're handling aircraft operations, and working with federal government representation, the National Science Foundation representation on site. So it's all, as you folks know, some of you here, that's a different environment than your normal workday, be it if you're only working for DOD and you're only working for a university, or if you're only working in a private sector. You really are working now with a lot of personalities, and that's also brought to bear. The NSF has a similar program, and I'm going to defer to the university on your protocol for hiring folks or bringing people to the Antarctic. Is it similar?
It's mostly word of mouth because
Yep.
we talk amongst ourselves and
Yep.
spread the word out.
Yep. Yes?
How likely is it that Raytheon's going to lose that polar contract?
I think that the answer is that it's a competitive bid, and the answer lies in the bid proposals.
Does
Yes?
NSF and the U.S. have an actual lease agreement with Venezuela and Chile that own the portion?
The territorial claims? No. The only lease agreements we have, for example, will be the country of New Zealand. We use the Christchurch International Airport for our C-17s and our 130 aircraft to land. All of us have landed there. They have facilities there that are the clothing distribution center where we change out of this type of gear to that type of gear and turn it back in. And there are administrative offices there, and there's a National Science Foundation representative in New Zealand located there. There are no leases that relate to the territorial claims, no. Okay. Thanks, everyone. Okay.
Thanks very much, Jerry. Thanks to everyone for coming, and to those of us visiting in Second Life, thanks for being with us. Again, there's a reception upstairs, so you'll have plenty of opportunity to ask Jerry questions one-on-one. Again, thanks for coming.